This multifunctional rebar detector is integrated and portable, which can estimate rebar diameter, test rebar cover meter, detect rebar location and distribution, and measure rebar's current condition. Introduction of ZBL R800. R800 consists of a holster, rebar sensors, rebar signal wire, copper sulfate electrode, double electrode handle, rust signal wire, U-disc, charger, and so on. All the control operations are done through pressing buttons in the keyboard panel. On the left side of the holster are round charging port, USB port, rebar sensor port, and rust electrode port. R800 detector has two sensors, large sensor and small sensor. Multi-parameter large sensor can scan rebar and record displacement of sensor in real time accurately. Single-parameter small sensor can only scan rebar and it can't record the displacement of sensor. When the sensor axis parallels with the direction of a rebar, it is the most sensitive. Conversely, when the sensor axis is perpendicular to the direction of a rebar, the signal is the weakest. Therefore, while mirroring, sensor axis should be parallel with the direction of rebar. Most importantly, when you detect cover meters, you should know clearly what rebar's cover meter you want to test, concrete rebars or concrete stirrups. When you test the rebar's cover meters, you should avoid the influence of stirrups. And likewise, you should avoid the influence of rebars if you need to test the cover meters of stirrups. For example, if you need to test the cover meter of concrete rebars, you should locate concrete stirrups and mark their position firstly. Then use the detection area of ZBL R800 to scan the space between two stirrups to test the cover meter of concrete rebars. When you test rebar current on the double pole method, you should install these two copper sulfate electrodes filled with copper sulfate solution on double electrode handle. To insert one end of the black rebar signal wire to the left side corresponding socket of host, rotating clockwise and locking, and then insert the other end into sensor socket and lock in the same way. Press right button to turn on screen backlight. Press enter button to enter rebar tester interface. Rebar tester has three test modes: general scan, profile scan, and grid scan. Up button and down button can move the option box and select the corresponding option and press the enter button to go to the corresponding sub-menu. General scan. General scan is the basic testing function of rebar test. Rebar's distribution, cover meter, and diameter can be measured precisely with this function. Press the enter button to general scan interface. Press enter button to set the object number. Move a cursor to the character to be modified through pressing right and left button. Press enter button, the cursor will move to the keyboard. Find the character you want through pressing the direction buttons, and then press enter button. The cursor will go to next character. Press the save button after setting all characters. Choose diameter through pressing down button, press enter button, press up button and down button to adjust the design diameter, and press enter button after completing adjustment. Revise design, cover meter, diameter, type, data correction, minimum cover, and choose sensor based on real project information. Data correction. In order to lower the effects for the measurement of cover meter of tested rebar by adjacent abreast ones, it's better to set center distance from adjacent rebar to tested rebar, and then the detector can modify test result automatically and improve test accurately. After setting all parameters, choose the Start Scan, press Enter button to go to Test Interface. Please hold the sensor in the air away from ferromagnets. After pressing Enter button, the instrument will reset automatically and the present thickness will show in blank. During detection process, a reset operation should be done about every 10 minutes. While doubt on the measurement data, measure again after resetting. Current cover. The current cover meter the equivalent distance between sensor and rebar. The larger the equivalent value is, the further it is. When equivalent value exceeding measurement range of sensor, it is 0. Cover. Display of measurement value of thickness of concrete cover automatically. If users use the data correction, it shows the corrected value. Diameter. Display the diameter of tested rebar. Pressing up button for the measurement of diameter when the sensor is just above the rebar, and the rebar diameter value will appear a moment later. Safe number. It is the stored amount of cover meter for present object. When the tested cover meter exceeds the range of specification, an exclamation mark will be presented, or it will be blank. The bottom line shows the object number, design diameter, status information, and qualification rate. Solid square in the information status bar represents small range, and the open square represents large range. Large range is suitable for large cover meter situation. The default range is small range, and you can change range through pressing right button. M represents manual storage, while A represents automatic storage. You can adjust through pressing left button. This icon represents denser rebar measurement, while blank represents general measurement. The default one is general measurement, and you can switch through pressing down button. C represents correction, while blank for no correction. Place a sensor on the surface of tested concrete and parallel with tested rebar, then move sensor along a direction in a constant speed. When the sensor going towards rebar, the signal value will become larger and larger, and the biggest signal value identifies the location of rebar. When sensor approaches rebar, the screw bar will lengthen gradually, and the location of longest screw bar is the exact position of rebar. When the sensor goes over rebar, the buzzer will alarm. Signal value is the fundamental basis of measurement of thickness of cover. When the change of cover meter is within 1 mm, the current cover value will not change, but signal value can reflect the minimal change. Therefore, according to it, you can locate the exact position of rebar more accurately. When sensor approaches rebar, the current cover value will gradually change to smaller, or the current cover value becomes larger. Location of minimum cover is the exact location of rebar. Placing the sensor above the tested rebar and parallel with it, press up button. After about 2 seconds, the tested result of diameter will be directly shown in the position of diameter. Under the mode of manual storage, if press Save button, it will store diameter and thickness of cover, and the storage amount increases by 1. Under the mode of automatic storage, it will store diameter value and thickness of cover automatically. After the test is completed, press Back button back to parameter setting interface, or press Menu button to go back to the main menu. Profile scan. Profile scan is a test displaying the location of tested rebar and thickness of cover with a sectional distribution map. Choose Profile Scan and enter Parameters Setting interface. Under this test mode, it is a must to choose Large Sensor to scan. After parameter setting, please select Start Scan and press Enter button to store parameter and enter into test interface. Do resetting first, and after resetting, press Save button to enter into test interface. A square cursor will occur in the top left corner, indicating the location of sensor. While testing, move sensor in a constant speed. When sensor goes over a bar, the buzzer will alarm. The tested rebar will be displayed in a corresponding coordinate, indicated by a black cross. The thickness or value of cover and the coordinates of tested rebar will be displayed in the upside of rebar, and the tested result will be stored simultaneously. The horizontal solid line in the central position is the design thickness value. The upper and lower dotted line are maximum and minimum thickness of cover. If the black cross appears under the lower dotted line, it means the rebar's cover meter is rather thick, and if the black cross appears above the upper dotted line, it means the rebar's cover meter is pretty thin. During the test process, when the tested thickness of cover exceeds the range of the standard requirements, based on design thickness, an exclamation mark symbol will occur or it will be blank. When the moving distance is more than 1.2 meters and go over the range of each screen, it will turn pages automatically. The X in the status bar displaying the amount of whole pages will increase by 1. The arrow in the lower right corner indicates the direction the sensor is moving. After the test is completed, press the Save button, press Back button to store testing data and go back to Parameter Setting interface, or pressing Menu button to go back to Main menu. Grid Scan. Grid Scan mainly displays the distribution of grid distributed rebar through grid diagram and display the location of rebar and the thickness of cover at the same time. Enter Parameter Settings interface. Diameter X, the diameter of a weighting mirroring rebar in X direction. Cover X, the thickness of cover of a weighting mirroring rebar in X direction. Diameter Y, the diameter of a weighting mirroring rebar in Y direction. Cover Y, the thickness of cover of a weighting mirroring rebar in Y direction. After parameter setting, choose the Start Scan and press Enter button to go to Test interface. Do resetting first. After resetting, press the Save button. A square cursor occurs in the upper left corner, showing the present displacement of a sensor. Scanning can be started in X direction as default. Moving sensor in a constant speed. When sensor goes over rebar, the buzzer will alarm. The tested rebar will be displayed in coordinate. Thickness value of cover, X-axis coordinates of tested rebar will be displayed in the upper side of rebar, and the tested result will be stored simultaneously. When X direction test is completed, press the Save button to end the storage state. Press Up button to shift to another direction. The default diameter and direction marker in Y direction will be shown in status bar. Press the Save button for scanning, moving the sensor constantly. When the sensor goes over rebar, the buzzer will alarm. The tested rebar will be displayed in coordinate, thickness value of cover, and the Y-axis coordinates of tested rebar will be displayed on the left side of rebar. In grid scan, screw bar can indicate the relative distance between the sensor and the tested rebar. When the sensor is closer with the rebar, screw bar will lengthen gradually. The current thickness value in the upper right will decrease accordingly, which is different from the meaning under general scan. When the scanning distance goes over the range of each screen, it will turn pages automatically. The increase by 1 in X and Y direction shows a page turned. After completing test, press the Save button and exit test interface. After testing, you can check the data or image through entering Data Display. You can delete data through choosing Delete Data. But make sure the data to be deleted have been transferred to your computer, as this operation is irreversible. Data analysis. Data transmission. Plug the U-disk attached with instrument into USB port and then select data output, and then press Enter button to enter USB options interface. Select Transfer Rebar Data and then press Enter button. Instrument will start up U-disk power supply automatically. Then, running OK indicates a successful transmission. Data Analysis. Copy the testing data to the computer and double-click Rebar Measurement Data Processing software on the desktop of computer. Click the File button on the menu bar and open the data file you want to analyze. On the top of the software interface is the title bar, followed by menu bar, toolbar, object information area. The object list is on the left side of the software interface, which shows all objects in the project, while on the right side are data table area and data diagram area. The data table area is used to display the original testing data of each measurement point of the current object, and this icon indicates no data. The data with yellow shading is the data higher than the allowed deviation range, and the data with red shading is the data lower than the allowed deviation range. The data diagram shows the testing lines or profile diagram of the current tested object. Take this object as an example, whose scanning mode is general scan, and you can improve object information on object information area. You can find this object's name is 000001, design cover meter and design diameter are 75 mm and 10 mm separately. Look at this data diagram area. Blue measurement points means the corresponding testing data is qualified, while red measurement point means the corresponding testing data is unqualified. Current test. R800 can detect the current degree and current distribution of rebar using the potential difference method. The worse the current is, the lower the conductivity is. And if the conductivity is good, current doesn't happen. Preparation before test. Before the test, the object to be tested must be fully wet and allow the water to completely penetrate into the interior to reduce the electrical resistance. But the moisture on the surface of the object must be wiped dry during the test. It's better to select area with rebar current signs or possibility of current. The area should be less than 5 meters multiply 5 meters. Distributing measuring lines on the surface of an object to be tested. Measuring lines in x direction and y direction constitutes a square grid. The crossing point of a measuring line is the measuring points. Generally, space of signal electric measuring points is set to 10 cm to 50 cm. Space of double electrode measuring points is fixed 20 cm. Every survey area should distribute 30 to 50 measuring points, and the distance between measuring points and the edge of an object should be greater than 4 cm. Configure copper sulfate solution. Configure saturated copper sulfate solution with distilled water and standard solid copper sulfate, and shake electrode appropriately, making copper sulfate solution reach saturation. Small amount of copper sulfate particles existing. Unscrew the upper rubber sleeve and socket, inject copper sulfate solution into the electrode, and the copper sulfate volume should be more than half of electrode volume. Firstly, soak a sponge with distilled water. When softened completely, screw to the electrode bottom. At the same time, keep a good contact between sponge and the bottom white ceramic chip. Connect instrument. If testing with double electrode method, it is necessary to install the two copper sulfate electrode on the double electrode handle. and connect the two electrodes to current sensor port of instrument with double electrode signal wire. If testing with the signal electrode method, it is necessary to connect a copper sulfate electrode to current sensor port of instrument with signal wire. Then chisel concrete in an appropriate position to expose rebar. The surface of rebar should remove rust and dirt to guarantee effective connection between rebar and the wire. Then clip rebar with the clamp of earth wire. Parameter setting. After connection, choose Rusty test to go to parameter settings interface. Choose a signal pole or double pole according to your requirement. In icon setting, different legend represents different potential value. The smaller black area of the legend, the smaller potential value is, or the larger potential value is. User can easily determine possibility of rebar current based on legend distribution in survey area. X dot pitch and Y dot pitch set dot pitch in X direction and Y direction, and generally the two values should be consistent. X dots and Y dots set dot number in X direction and Y direction. Range of a single electrode and double electrode mirroring points is 1 to 18 in X-axis and 1 to 13 in Y direction. On-site test. Mirroring interface is composed by result display area and parameter area. The top of the screen is the result display area with legend to show mirroring result of every mirroring point, and different legends represent different potentials. The lower part is parameter area displaying current coordinate, object number, current tested potential, and test direction. The cross at the upper left of the screen indicates the position of the electrode. If it is a single electrode test, place the electrode on the first mirroring point from the left end, and make sure sponge fully contact the mirroring point. And at the same time, the corresponding icon to the conductivity of the mirroring point will be displayed on the screen. After the icon is stable, press the Save button, and then we finish the test of first mirroring point. After testing the first row of mirroring points one by one, the cross will automatically jump to the starting position of next row, and start the test of next row of mirroring points. If it is a double electrode test, place the double electrode on the first and second mirroring points from the left end, and make sure sponges are in full contact with the mirroring points, and the conductivity icon appears on the screen. Press the Save button after the icon is stable, then move the double electrode to the second and third mirroring points for testing, followed by the third and fourth mirroring points. Test all the mirroring points in the same manner. Press Back button or Menu button after completing test, and you can press Data Display to check test data. You can delete all test data through pressing Delete Data, but before deleting, make sure all data have been transferred to a computer, as the deleting operation is irreversible. Current data analysis. Data transmission. Plug the U-disc attached with the instrument into USB part, and then select Data Output, and then press Enter button to enter USB Options interface. Select Transfer Rusty Data, and then press Enter button. Instrument will start up U-disc power supply automatically. Then Running OK indicates a successful transmission. Data analysis. Copy the testing data to computer, and then double-click Rebar Rust Test Data Process software. Click File. Choose the data file you need to analyze. The software interface consists of a title bar, menu bar, toolbar, object information area, object list area, data area, object view area. Object information area shows the object number, dot page of X and dot page of Y of the tested object. Object list area shows all objects in the project and their validity. Data area displays the original testing data of measuring points of the object. This icon means there is no testing data in this measuring point. Object view area displays the testing data in 6 different ways: data table, grid image, detection data, contour graph, frequency map, and statistical result. Through tools, export to Excel, you can generate an Excel file.